Okay, well, welcome everybody to Solar Noon Tuesday. And as per usual, we'll go ahead and start with the solar news of the week. And so this week, actually, there was quite a lot of news. A study from Duke Energy found, they actually studied about 210 plants, and they found that coal power plants, just to fuel them and maintain them, ends up costing about twice as much as building a brand new solar array. So that explains quite a lot why a number of these coal power plants are being retired. In fact, EIA announced that over the next 6 years, about 27% of all of the coal power plants in the US are scheduled to be retired. And that comes on top of the fact that in the last decade or so, about 40% of the existing power plants have already been retired. These are coal power plants. So clearly coal is dead and dying, and it's really a matter of economics there. First Solar, as part of this transition to solar away from traditional fossil fuels, they announced they're going to be investing about $4 billion in expanding their production capacity. Most of their production capacity is in Ohio, but they are opening up another First Solar manufacturing facility down in Alabama. There's an interesting podcast that's out there. If somebody wants to get the link, I'll have to look it up, but I listened to it about the history of First Solar and Toledo Solar. They both came out of the University of Toledo, and they are the largest manufacturers of thin film panels in the United States. First Solar focuses primarily on utility scale systems. And one of the reasons they're investing in so heavily in their production is their production has now been sold out through 2026. So if you wanted to place an order as a utility today, you could not expect delivery until 2027 for those panels. So it's an example of not only the demand that's going on, but also with the with the Inflation Reduction Act, there's a push towards American-made panels, and First Solar is the largest of those. Another thing in the supply chain that's tied to the IRA, the Inflation Reduction Act, is that REC Silicon has announced that not only are they reopening the silicon manufacturing plant that is located in, let's see, where is that located? It's in Moses Lake, Washington. But they've already sold out all of their production to Hanwha for the next 10 years. So they're opening up this plant, and product is completely sold. Let me see. Hey, Jay, could you mute your thing? All right. And then, thanks. The power purchase agreements for the prices of wind power purchase agreements. This is when a large facility, a large wind farm sells to the utility or to some other company. The prices have been going up, and they've been going up pretty steadily here in recent years. That follows the trend where prices from renewable energy have been declining and declining and declining. But really since COVID, we've seen a dramatic uptick with largely because of supply chain disruptions, but also fossil fuel prices have gone through the roof. So renewable competes with fossil fuel. So when one goes up, the others will, of course, go up a bit. There are also interconnection issues. So there are several year delays for some of these bigger systems to get onto the grid. And of course, increased demand. So prices for wind did fall in the fourth quarter by 1.9%. prices for solar increased by about 8.2%. And that really means that over the course of 2022, the power purchase agreement price for solar was up about 33% over 2021. So pretty dramatic increases. From this chart, you'll see that actually the prices there are still for solar in about the $3.5 range there per, or I should say 3.5 cents per kilowatt hour, or $35 per megawatt hour. So that's still pretty low. That's a wholesale rate, of course, and then they would mark that up. Obviously, if you're paying retail right now, you know you're paying a heck of a lot more than, say, 7 cents, which would be a traditional markup for a utility. They would buy at 3.5 cents, sell it at 7 cents. Traditionally, they've been buying it about 6 cents, selling it at about 12 cents. Now what they're doing when they buy wind and solar, buy it at 3.5 cents, sell it at 15 cents, deal for them. So we'll see if those prices are ever going to come down. But at least for the solar and wind producers, they're starting to see a bit more money. CEA, the Solar Energy Industries Association, announced they think that the IRS will miss their deadline. The deadline is February 13th for guidance from the federal government as to how to deal with the Inflation Reduction Act. All of these benefits now, all these tax credits are out there. Nobody quite knows how to comply with that. What constitutes domestically made product? What constitutes an area that is fossil fuel dependent? All of these things are tied into it. So we've been flying kind of blind. CEA anticipates it won't be until the second quarter of 2023 before the IRS comes out with their guidance. We did discuss this a little bit last week, which was interesting. ChargePoint has announced a deal with Stem, which is a storage manufacturer, that they're going to begin integrating storage in their charging stations along highways and the like. The reason for that is it will lower operating costs. It will provide for increased resiliency, mitigate over peak demand periods, and protect against pricing changes that the utilities may put into place. We were talking about before about how the demand charges really do impact the pricing. And so we could somehow even those out where you've got some sort of storage device. That storage device recharges the car when it's hooked up to the charging station, and then solar or wind or even the grid recharges that storage device, which is then used to recharge the battery. That way, you don't get this huge influx of power going from the grid to the charge to the car, which would increase the demand charges on the bill. So we're starting to see now storage integrated into charging stations, just as we talked about last week in this call. Hot Springs, North Carolina is now a microgrid. It's been set up by Duke Energy, and this is an example of some of the innovations that we're thinking are going to start to be widespread across the country. Hot Springs is a resort town right next to Asheville, population less than about 1,000 people. So it's a small test case. They're installing about 2 megawatts of solar, about 4.4 megawatts of battery backup. This will provide the entire town about 4 hours in case there's a power grid disruption. But also for Duke, it'll allow for frequency and voltage regulation so that they can clean up the power as it flows through these large batteries. You basically convert it from AC to DC, and then when it comes back out of the batteries, the waveforms are pretty much perfect. So they've cleaned up that power, and they can also manage peak load demand for not only the city, but they can draw on these batteries for other activities. And when there's peak load demand elsewhere. Illinois recently passed House Bill 4412 on January 27th, and this bans local communities from prohibiting wind and solar. So there's been an uptick of that going on where a lot of the lobbying starts to take place at the local level. So you get a wind farm that's going to be developed or a solar array that's going to be developed, and a lot of the competing forces come in with a lot of big money and start promoting, everybody getting all hyped up that wind turbines are going to give them, give their cat cancer or whatever they come up with. And so anyway, so that's now a law in Illinois that these local communities can't ban these projects just out of spite. And Minnesota on February 3rd just passed a law what's the right word? Anyway, it's hoping to obtain clean energy, 100% clean energy by 2040. Now it's one of 10 states now nationwide where this is the goal. And those are Washington, Oregon, California, New Mexico, Illinois, Massachusetts, Virginia, and Hawaii. But there are 9 other states that are looking at similar legislation. I can't believe, now this is what the article said, but I can't believe Texas is moving towards 100% clean energy, or even Florida, but you never know. But at least they're considering bills that are similar in nature. And that's the news from solar for this week. Does anybody have any comment on that or anything else they want to bring up for the good of the cause there?
Yeah, with first solar situation, since most of the silicon materials already been brought up, where do they plan to get the silicon wafers?
Yeah, that's a good question because, of course, about 95% of the world's silicon ingots and cells come from China. And there's been a big issue there because most of them come from the Uyghur region in China, and there's a lot of forced labor that's involved in that. So in the United States anyway, we passed a law saying that you cannot now import those from the Uyghur district. So that's eliminated a big amount of the supplies. So then the Inflation Reduction Act has asked that there be domestically manufactured product. So for the U.S., they're looking to to make the silicon, mine it, process it in the United States. But that's going to take time for that to develop. I know Australia's got some silicon reserves. The big I think Norway, didn't we hear? Norway and Sweden are getting into that. So I'm not quite sure. I mean, this is part of the reason of the issue with supply chain disruption, because 95% of the process and it's been very systematic in how China did this. Remember, I mentioned REC Silicon closed that plant in Moses Lake, Washington in 2019 because they couldn't compete with the prices from China. Well, China was basically using slave labor. Well, it's hard to compete against that, when they're doing that. So the whole world has to transition from that kind of supply chain to perhaps a more expensive, but a more dependable and certainly more humane supply chain of localized production. So I don't know where Trinidad's going to get theirs, Devanan, but the boats sail right past there. I guess you can hijack a few boats delivering silicon.
Well, basically, we could import directly from China. We do have to come to these states, right? And sometimes we get retail price as low as 19 cents per watt. For some brands, Longi. I just got a quotation for shipping costs and ocean freight charges to Trinidad was like about $2,500 US.
Oh, really? So the prices there have come down pretty dramatically.
Yeah, dramatically.
Yeah. Okay. Well, you guys in Trinidad, of course, may benefit from the fact that the U.S. is no longer in the marketplace for Chinese product. I mean, they're still going to be producing stuff. They're producing it for their domestic market. They'll produce it for other marketplaces that don't have the same kind of sensitivities or regulations that are going to prohibit that. So I don't know. Another thing that I think we're probably going to see is just what we're seeing in First Solar. They don't use silicon. They are a thin film process. So, that's going to be quite a, if we could go ahead and change all of that to where we're no longer basing the majority of our activity on silicon panels, but we start to get into the, cadmium telluride or something like that for the thin film. And then of course we get into perovskite, which is again not a silicon-based thing. So we may see that the supply chain of silicon starts pushing folks into the thin film marketplace. And actually in that podcast I was listening to from Toledo Solar, there are some really good arguments for switching over to thin film. Thin film may actually do better than silicon panels in a large amount of cases. Always before we've learned, and I've taught in my classes, that the best is monosilicon, that you get into polysilicon, and then of course thin film. Well, that's changing as the technology is changing. And, there's a reason why the utilities are all installing thin film panels. They have longevity. They operate better under conditions that are more normal out in the environment. They handle heat better, those kind of things. So we may see a transition that happens there fairly
quickly.
Yeah, fairly quickly there. All right. Any other questions?
Jay, I wanted to ask the group if anyone has had any experience with AP systems, micros.
AP systems. Anybody involved in, I know AP manufactures microinverters, but they also, I think, do larger inverters as well. Anybody worked with AP micros?
Okay. They have an odd policy of not supporting do-it-yourself installers. I actually had a micro come to me straight from Renvu, is where I buy their equipment, RENVU, out of New Jersey. And the micro had melted MC4 connector on it. So actually the plastic was melted and they wouldn't honor the warranty claim on it because I cut the AC connector off because it was right there by the junction box. I didn't need to extend it, the AC line, so they're kind of nasty that way.
Yeah,
just
I can
curious.
imagine. Did they explain why it melted? Was it like an arc thing with a bad MC4 connection?
No, they wouldn't even, you would think they'd want to know about quality control from the customers. They didn't even ask any questions, just you can't return it. You cut the AC connector off, so it's not going to be warranted.
Huh, that's weird. I know we've discussed before some of the issues with interoperability of MC4 connectors. When you're making those connections, obviously, if you're hooking them into their proprietary cable, that should not be an issue. But when you're hooking MC4 connectors together that are not exactly the same, you can run into some issues of arcing and overheating of those connectors. So that's a big issue, one of the leading causes of fires on rooftop solar arrays. So I don't know if that's the case. I doubt it is, but it might have been that they just set it on a hot stove or something for all we know. So,
Hey, Jay.
Who knows? Who knows?
Yeah. Hey, Jay, do you know anything about the 20-year mining ban in Minnesota when the rare metals had copper, nickel, things like that?
No, I don't. I mean, Minnesota is a large mining area with the Iron Range up there. So I've not heard that.
They just instituted a 20-year mining ban on 225,000 acres up there.
Huh. For everything, or just you say rare earth metals or something?
Can I chime in here a little bit?
Sure.
Yeah.
Yeah. So that mining ban is to protect the Boundary Waters Wilderness area up there outside of Ely, Minnesota. And I had been up there, and it was quite controversial with the locals because it was going to bring in quite a bit of revenue, but they couldn't assure that pollution was not going to leak into the boundary waters. And so President Biden set aside the land on a 20-year mining ban.
Okay. Is that public lands up there that are being protected?
I don't know specifically, but the majority of the ownership up there is public lands. And I'm sure that what the mining companies wanted to get after was going to impact the boundary waters in a very negative way. I feel pretty strongly about that, having spent time up there and seeing some of their very large open pit mines. So that's what I know about it. A little bit of personal experience from being up there.
Okay. All right. Well, hopefully that answers. We'll find out. At least it's not directed at the solar industry anyway. That's that's good. Any other questions or comments before I jump into this week's topic? Just looking over to see. All right. Okay. Well, what I thought we'd talk about here this week is, I'm blocking myself there, is Enphase. I just saw an article this week that Enphase is releasing a new bi-directional EV charging station. And that charging station is going to be available in the sometime in 2024. So this is at the moment theoretical. There was a program with basically they bought another company, or they've got a partnership with another company that makes charging stations. And we're starting to see this happening more and more as there's a lot of money being put into electric vehicles. We're seeing a transition to electric vehicles, and Enphase now has a proprietary solution to their EV charging. And this is a it's interesting because it's an AC. It will convert it in the charging unit to DC, or it will feed through to the vehicle and then recommunicate back. I know that there's a battery and there's some inverters in that charging station. So it's not just a dummy extension cord that's running out there to the vehicle. They're arguing that, of course, one of the advantages of bi-directional charging is you can do vehicle to home. From a personal perspective, I've got Enphase inverters on my array, and I'd like to see, can I use an electric vehicle as the battery backup for my home? Well, according to this, yes, I will be able to do that. I'm not sure if you have to have batteries in addition to. That's something that was not in the literature when I tried to look into it. There's also vehicle to grid. We've seen some of these announcements where companies are looking to essentially accumulate or aggregate all of the battery backups that are in the Enphase world or in the Tesla world, and creating virtual power plants so that you could then resell back to the grid. Or for instance, in California, they have that deal that during peak load emergencies, they will buy your power at $2 a kilowatt hour. So you might want to produce and feed back at that time. Green charging, well, that sounds like buzzwords, but basically you can charge from your solar array at this point. If you've got time of day pricing, then you can start to use your EV as a way of doing load shifting, peak load leveling, things like that to save money on your electric bill. All of the same things you would do with a stationary battery, now you can do with your electric vehicle. Self-consumption, that's a big deal out there now, with the utilities beginning to reduce the amount of money they're paying when you feed back to the grid through net metering. So we're seeing this nationwide as a trend. They're moving away from retail to retail, where in net metering, your meter runs backwards, your meter runs forwards, and you only pay the net amount, which is effectively getting paid retail if you're sending power back to the grid. Now they're paying you wholesale, but you're buying retail. So under that scenario, why would you send power back and get paid wholesale when you can store it in locally and then use it to offset retail purchases? So effectively, you get paid retail under that scenario, but you have to have some sort of battery system. Well, the EV can now serve in that capacity if you've got an Enphase system there and if it's installed. So then I thought, all right, well, how does all of this stuff connect up? So I wanted to do a little bit of research because we're in a bit of a deeper dive here than most locations. So this was the schematic that they were putting in some of their original marketing. Now, bear in mind, all of this is still vaporware until, you know, the product's out there on the marketplace. But you'll see in the center here, there's a system controller or their smart controller, and you're connecting into the grid. I've got a better diagram of that a little bit later here. And that controlling unit is where you hook up your solar array, and you typically are going to hook in there from a combiner box. You know, you're going to bring in your branch circuits from your Enphase circuits into the combiner box and then feed into this controller. You also hook in your batteries, whatever batteries you've installed, those hook into that controller panel as well. And then you hook in your EV charger into that same unit. So it's pretty simple when you look at the diagram. Again, I'll show it to you, but it's really just a port. It says, you know, here's your connection for the for your solar. Here's your connection for your storage. Here's your connection for your EV. All of those are going to be AC connections. They communicate out there through the cloud. In the Enphase system, the communication device is located in the combiner box. So it's in a different unit, but all of these things communicate wireless with each other. It does have a port for generators if you have a generator backup system. And they've even said fuel cells. I can't imagine somebody having that. And from that, it would then head off to your service panel. This smart unit, this systems controller, just to give you a sense of the cost on it, is going to be about $2,000. At least that's what they cost at the moment. I did find some out there that were a little bit cheaper. Some were a little more expensive. I'm not sure if this pricing here, $2,040, includes, it obviously includes that rapid shutdown switch, but I'm not sure if that's included with all of them or if this is a little bit of an add-on. But again, bear in mind, you're going to have to install that rapid shutdown switch near your meter because you've got batteries now. And the purpose of that AC disconnect is when they turn that off, they want everything in the building to essentially go dark. Well, if you've got battery backup on your system, you disconnect from the grid, then the batteries are going to kick in, or your electric vehicle is going to kick in and start supplying power to the home, maybe to the entire home. It may just be critical loads, but they don't want that because it's to protect firefighters so that there are no live circuits when they start chopping through walls or cutting through the roof or whatever. So you've got to have a rapid shutdown switch out there next to your AC disconnect that will turn off all your batteries. It'll disconnect everything, you know, right at that location. So that's going to be integrated in. So when we look at the AC, the Enphase system here, this is the diagram from the when you start hooking up. Now, it doesn't include the EV charging station yet in this, but I'm sure they'll simply integrate it in. But you'll see that typically from the solar array down, those microinverters are going to connect into the combiner box. The combiner box is where your communication system is, and that then wirelessly communicates with the battery bank. You'll connect in your combiner into the port there in that smart controller, or the IQ system controller 2, which they're calling it. There's just a port there. It's going to be an AC connection, just the two hots, the neutral and a ground. And then you're going to connect in your batteries into the slot there in the controller. There's the rapid shutdown switch connection. This unit connects directly to the grid. So from your meter, you're going to take the lines that traditionally head into the into your service panel, and they're now going to head into this controller unit. So that controller unit's got to sit somewhere close to the meter. You know, it could be in the basement next to your service panel. That probably a pretty good location for it, out of the weather and everything. Then from there, you're going to also go from that unit to your main panel. Inside this controller is the auto transformer, or the automatic disconnect switch. So when it loses sight of the grid signal, it is going to go into standalone mode, and it's going to disconnect not only from disconnect from your main panel. So there will be no power, it's going to disconnect from the grid in case, so you're not back feeding the grid there. But it will redirect power from your array, from your batteries, and from your electric vehicle into the power units, into your main load panel. And then you can integrate load control. And I think this is going to be something that's becomes the norm. Always before, when we talked about AC coupled and DC coupled, we talked about a diagram that was closer to this next diagram here. If we've got, what happened there? Did I put the same exact panel there? No, there's a sub panel. Yeah, this is the one I wanted here. When we talked about you didn't want all of your loads to be serviced by the system, well, now you've got a sub panel. But this is a bit more complicated. You're hooking into your main panel, into this. So you're going from your grid to the main, and then from the main, you're hooking into this, and then you go to a sub panel. That requires a lot of electrical work in your home if you don't have a critical load panel already installed. So I think what we can do is all of the same benefits you get from servicing through a critical load panel, we can do here with a whole house backup, but using down in the just left of the main panel, the load controller. So you can begin to control at the circuit level your feed. So you can essentially shut off all of the breakers you don't want to use when you're in standalone mode. You can do that programmably as opposed to physically. So I think this will be the norm. And I can see a lot of advantages of this kind of system because, what you consider to be a critical load may change over time. So now you don't have to go making physical changes to the wiring system. You just simply say, okay, now the garage door opener is no longer a critical load, but my microwave is. So, that's something that you can program into your phone for that purpose.
Jay, is that something that can be set up with other than an Enphase system? I mean, is that something you could go out and buy a different mod or a different brand or something?
Yes. In fact, your service panel, you can either buy a smart service panel, but there's a lot of second, aftermarket hardware things that integrate in with the various service panels where they just hook up CTs to each branch circuit in your home. And you can control it that way, or you can even control it at the load level by having smart plugs that can be managed through your software, where you're simply plugging an appliance into a smart plug. So I think that's something, I know yours is a standalone system of sorts, but it's certainly something you could add today, and they're fairly reasonably priced. I know I was looking at some of those not too long ago.
Okay, thanks.
Yep. I think we'll start seeing electricians go ahead and install smart panels just as a matter of course, because you may as well. I'm sure the cost is going to add a couple $100 to to the install. But when you're building a new home, a couple $100 is, you know, nothing, especially if you go down. I just went down and bought 20 feet of Romex regular 12 gauge wire. It was like $27. I was, oh, geez. So yeah, electrical materials, pretty expensive at the moment. Any other questions on the Enphase stuff?
I could definitely see a big advantage in savings time and installation, because having to rewire from main distribution panel into sub panel is a headache by itself. Wiring can use back, you have to change the wiring. So putting that smart controller distribution unit, I could see where that saves quite a bit of time.
Sure. Yeah, I was thinking about, because I'm sitting here in our office in Marietta, and we're going to be installing a system, and I'm really wanting to look at this one as an option. But I was thinking through all of the different places I've got to put this stuff. And the smart controller logically seems to make sense to put it in the basement next to the service panel. But if I want to hook in an electric vehicle charger to that, well, the electric vehicle charger is going to be about 100 feet back next to where the parking space is. And if I'm using my electric vehicle as the backup, the wire that's going to go from that electric vehicle is going to be pretty robust. You know, it's enough to service the loads that I want to run. So I might be looking at, say, 100 amps. So now I've got to run some pretty heavy duty cable 100 feet to hook into that charging station, hook into that controller. That's not the most ideal. The problem is if I locate that back there where I'm going to have my charging station, then I'm going to have the same issue running it up to where it connects into my service panel. So the EV charging station is definitely going to add a bit of cost to the wiring, especially, well, if it's bi-directional, there's just no way around it. You've got to get the power from the battery to your main distribution panel somewhere or other. And those things are usually not conveniently located next to each other. So,
Jay, Bruce,
yeah.
What about, I think we mentioned this, I don't know if you covered this, maybe I missed it. Say I don't have a garage and I have my vehicle parked at the curb.
Yeah.
How am I gonna, is there a method, a hardwire kind of a thing that I could, without channeling my sidewalk?
Yeah. I don't even think you'd be allowed, you know, I mean, that's a real problem. We talked about that as far as how do you deal with EV charging stations if you live in an apartment complex. You know, they might provide you one parking space, but most people have more than one vehicle. Street parking, how is all that going to work? Because you're, you know, if you want to go ahead and say, I'm going to put a charging station out next to the curb, well, that's not, you know, there's public right of way there. It's not necessarily something the city's going to let you do. And then how do you protect that from other folks using it? You know, you could lock it up or whatever, but locks have a way of getting cut off. I don't think anybody's come up with a good solution, Bruce, on that. So I think someday, if we're looking out into the future, I can see electric charging parking spaces where it wirelessly charges from the undercarriage of the vehicle. You know, when you pull on, it just simply, you know, does a very short distance transfer, power transfer to the undercarriage, sort of like what you do when you lay your mobile phone on a charging pad. But that's a ways off for sure. It sounds like a business you could start up, Bruce, coming up with a solution there.
Yeah, Tony's not on here.
Oop, I lost you on that last comment.
I said, Tony's not on today, is he?
No, Tony.
Okay.
Yeah, it's gonna. Yeah, well, you can
tell Tony.
go into business with Tony to set up the charging station.
Probably fry some cats that way.
Yeah, that would, well, you know, side benefits, I guess. So I'm going to get in trouble over that one. We were just talking about the call before, how people are offended by things. Okay. Any other comments on the EV charging or the Enphase system itself?
Yeah, I'm
I
here.
think,
Yeah, go ahead, James. James.
Yeah, I just want to introduce myself. Name's James, and I'm new to this discussion, and I'm enjoying it. And it just so happens I know a little bit about Enphase stuff. I'm a bit of an Enphase fanboy. There was discussion about energy management, which is, in my mind, equal to energy production. And with any kind of energy management system, you want to access the state of charge of your storage, because that way you could modulate your exports and promote self-consumption, as you talked about. There's a couple of companies that integrate directly to the Enphase through API connections. And then there's other ones, as you mentioned, that require separate sets of CTs. But one company that integrates directly is Lumen, and that they make a panel, a smart panel, and they also make some affordable devices that can control loads at the local level. So you can drop out loads when your solar production decreases. You can drop loads when your state of charge starts going down. You can add them back and so forth. So that's one comment I want to make regarding the energy management. The second part is important for people who have used Enphase, especially this controller, is that all the new products are going to be CAN bus connected. So in the past, the Zigbee has been a bit of a limitation where you can put equipment, but with the new batteries and the controller and that smart bi-directional charger are all going to be CAN bus connected with cables, hardwired. And so that's kind of a big thing for people who've had Enphase things. The bi-directional charger, it's more of it's a real thing, because the controller already has a generator port. So it's not such a big difference to connect an EV versus a generator. The delay, I think, from what I'm hearing in the availability of that product is coordination with the EV manufacturers themselves. And there's a lot of discussion going on with the EV manufacturers. There's a lot of competing interest, financial interest, and technical standard interest. But each company wants to promote their own system. Ford has a system and a partnership. BMW, Hyundai, I all have partnerships with home energy management system. How it's all going to sort out, I don't know. But the Enphase system is based. The inverter is bi-directional, and basically it's just a bunch of microinverters in that box. So they're the same microinverter technology that would be used in the battery. The Enphase battery is a bi-directional device. It works both ways with the battery. So that charger, or bi-directional charger that Enphase is promoting, is going to work exactly like their battery.
Okay.
My kind of question that I have and to watch is the amount of power you can get through that charger. The EVs have a tremendous amount of energy, and you can tap into, but it's going to be kind of a bottleneck getting enough energy and power through that to run, say, a 3-ton air conditioner or something like that. So. Sure.
Yeah. In fact, I know that it's going to be controlled, or it would have to be controlled based on the breaker that you've hooked that up to. I mean, obviously there's limitations on the amperage that'll go through whatever wire you hook up. I'm sure the output from that will specify, just like everything else, it's good up to X number of amps. And that was not information that I could find yet from the EV charger.
Absolutely right. Again, thanks for letting me comment and join the discussion.
Sure. That's what, yeah, I think just to follow up on a couple of things you raised there, James, I did see that they're talking about, is it CCS and CHAdeMO for protocols for charging. So they're looking at that at the moment on their system. And the other thing I thought I would mention, which you reminded me when you're speaking, is that the Enphase 8 Pluses currently have the capacity to operate in standalone mode without batteries. So that's a bit of a different technology. And I did see when I was looking through the installation manuals that the hooking up of those systems to that smart controller is different if you're using 8s or 8 pluses versus if you're using legacy charge controllers like, you know, the 7s, the 6s, I guess even the M250s. That's something I'd have to see. It seems to me when I researched this before that the M250s and the M215s do still work with it, but under some limitations. So that would, if not, I mean, that would be a real bummer not to be able to use this controller with some of that legacy equipment.
That's right. And just a little bit more on that, the 8 series microinverters have the ability to form a microgrid without a battery.
Yeah.
And where the previous generations require a battery. So I'm sure that if the EV was there, it would provide the reference for voltage for any earlier series micros to join a microgrid. But the whole thing is, you know, is your truck in the parkway or is your car in the driveway? You can't get a wire out to the street. And with that, I think if you look to Europe, a lot of people have EV chargers at their workplace.
Yeah.
And what's going to happen is people are going to gain time of use rates and grid services by, you know, having different places to offload their electricity if they think it's to their financial advantage. So that's all there.
Yeah, we've got a lot of things to work out as we electrify the vehicle fleet here. Any other comments? I know there was somebody who was speaking just a moment ago. Devin?
Yeah, I was just asking about the Enphase controller. I was really going to ask if there are limitations on the sizing of it. But I think you answered the question, not sure how much current max they could support. And the other question I wanted to ask, does the system cater for DC fast charging or those kind of power ratings and voltage?
Oh, you mean on the Enphase? No, this is really a home system. So it's going to be a level 2 charging station, no doubt, because everything is AC 240, at least in the US. So because remember, everything's going through the Enphase inverter, so it's going to have an AC output. So it's not going to be a DC to DC fast charging system. Now, I do know the voltage limitations on their combiner box is 80 amps. You can put in 4 20-amp circuits, input circuits. So my guess is they're probably going to follow some sort of protocol like that. If you needed more than that, you know, if you need more power than that, you've got to put in 2 combiner boxes. So why not then 2 charging stations, you know, treat them as separate entities. But that would be my guess, and it's completely uninformed. I'm just throwing a number out there that seems to make sense based on their past behavior. So anyone else have a comment?
Jay, I just read that Lordstown Motor Corporation is going to be producing a new fleet pickup over there in Ohio.
At Lordstown, for which company is that for?
Lordstown. They're being backed by they bought the General Motors plant.
Oh, okay.
And Foxconn is going to back them.
Okay. Yeah, I think we're definitely going to see a lot of this development. Of course, we did bring up that pretty much every major manufacturer is going fully electric by 2040. So if you're going to do that, now's the time you got to gear up your manufacturing. And fortunately, in the industrial Midwest, like where we're at here in Ohio, but the Ohio, Michigan, they're beginning to see a lot of the benefits of the retooling towards the renewable energy economy. So, right. Any other comments before we call it a day? Okay, seeing none, I'll see you guys all next Tuesday. All right, take care. Thanks for joining.